Hey everybody, in this video we're going to look at the sum to infinity for a geometric series. Now for the sum of a series to converge or come to a specific value, the ratio r must be less than 1 in magnitude, and here's why. When r is 2 and the first term a is 1, well the sum of the series will be the first term of 1, the next term, so 1 times 2, the next term, and then the next term will become 8, so the sum will just keep growing and growing indefinitely, and never settle on a number. But if the ratio r is less than 1, each term gets smaller and smaller, because you're multiplying by a fraction. If we look at this example, when r is a half, and the first term again is 1, then we have the sum will be 1, next term a half, next term a half times a half is a quarter, and then a half of this will be an eighth or 0.125. And similarly, if you keep adding smaller and smaller numbers in the series, the total grows but at a decreasing rate, and eventually it adds up to a specific value. That's the sum converging. So when the ratio r is less than 1, you're essentially adding up an infinite number of terms that get smaller and smaller and smaller. And mathematically, this infinite sum approaches a finite number, which means the series is converging. So if we look at how this works with our formula, for large values of n, r to the n will tend to 0, when the magnitude of r is less than 1. So the sum of a series for an infinite number of terms will be a, because this will be 0, 1 minus 0 is 1, so it's just a times 1, which is a, over 1 minus r. So in example 2, I'm going to show you a numerical series where we can apply this formula. Okay, so we've been asked to find the sum of each geometric series using the formula we just worked out a minute ago. So in this series, for example A, we can say that A, our first term, is 1. The common ratio will be 0.1 divided by 1, so 1/10, and the number of terms is tending to infinity. So we can put these three values into our formula. So the sum to infinity will be a 1 over 1 minus r, 1/10. We can simplify this denominator, and we get 1 over 0.9. Then we can work this out, and we get 10 over 9, or 1.1 recurring. So the sum will never actually get to 1.1 recurring, but it will converge to this as n tends to infinity. Okay, so for example B, we can see that the first term is 16, so a is 16. The common ratio is a half, and again we're looking at an infinite number of terms. So we can put these three into our formula. So the sum to infinity will be a over 1 minus r. We can simplify the denominator, so we get 16 over a half, and this will converge on 32. For example C, we can see that our first term is negative 64. Common ratio will be 48 divided by negative 64, which simplifies to make negative 3/4. And again, we're looking at an infinite number of terms. So we'll put these three into our formula. So the sum to infinity will be negative 64, our a value, over 1 minus negative 3/4. We'll simplify our denominator, and then negative 64 over 7/4 will be negative 256 over 7. So this is how you apply this sum to infinity formula for different numerical series. In example 3, we're going to look at problem solving with this. Okay, so for example 3, we're told the first and the fourth terms of a geometric series are 81 and 24, respectively. We've been asked to find the common ratio, the sum of the first 5 terms, and the sum to infinity of a series. So the first thing we're going to do is we know the first term a is 81. The fourth term is ar cubed, and this will equal 24. So now we need to work out a. And we can do this by dividing the fourth term by the first term. can you see that the a's will cancel when you divide ar cubed by a? So we're left with, these will cancel, so r cubed will be 24 over 81. We can simplify this fraction, so we get 8 over 27, and then we can take the cube root of both sides. So our common ratio will be 2/3. So now we've got the common ratio, and in question B, we've been asked to work out the sum of the first 5 terms. So in this case, n equals 5. And because we're looking at the sum of the first 5 terms, we're going to use this formula. So we'll substitute these values into here. So we get the sum of the first 5 terms will be 81 multiplied by 1 minus the common ratio to the 5 over 1 minus 2/3. And we can work this out on our calculators, and we get 211. So the first 5 terms in this series will have a total of 211. For question C, the sum to infinity of a series, we know we can apply this formula because the common ratio has a magnitude less than 1. So the sum to infinity will be a over 1 minus 2/3. We can simplify this, 81 over 1/3, which is 243. So you can see that if we have an infinite number of terms, this is not much different to the sum of the first 5 terms. So let's move on to example 4. So in example 4, we're told the sum to infinity of a geometric series is 250, and the sum of the first 3 terms is 234. We've been asked to find the common ratio and the first term of a series. So we know the sum to infinity is 250, so we can substitute this into our formula. We'll call this equation 1. And then for the sum of the first 3 terms, well, we know this will be the first term plus the second term plus the third term, and we'll call this equation 2. So now what we can do is we can use equation 1 to make a the subject and then substitute that expression for a into here. So a will be 250 multiplied by 1 minus r. And then we'll substitute this expression for a into equation 2. So 234 will equal the first term, a, the next term, a times r, and the third term, a times r squared. Now we can divide through by 250 and factor out the 1 minus r. So at this point, we can expand out this bracket with this bracket. So we get 1 times 1, 1 times r, 1 times r squared, negative r squared, and negative r cubed. We can simplify the right-hand side because this positive r will cancel with this negative r. This positive r squared will cancel with this negative r squared. What we're left with is 234 out of 250 will be the 1 minus r cubed. We can move the negative r cubed over to this side and the fraction to the right-hand side. So r cubed will be 1 minus 234 over 250. We can work this out on our calculators. So r cubed will be 8 over 125. Then to work out r, we can take the cube root of both sides, and this will give us 2/5. That's the common ratio. In part B, we're asked to find the first term of a series. Well, if you look at equation 1, well, we've got our common ratio. We can use this to work out our first term, a. So we'll substitute 2/5 into here. We get 250 is equal to a over 3/5. We'll move these 3/5 over to the left-hand side. So a will be 250 multiplied by 3/5. We can work this out, and the first term will be 150. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.